When we look up at the night sky, we see billions of stars. But have you ever wondered, is our universe the only one? Scientists are not only considering the existence of other planets or galaxies, but also the possibility that there are entirely different universes beyond our own. The idea of the multiverse is not just science fiction. Many leading scientists take it seriously. So could there really be other universes out there? Let's explore. For centuries, humanity has pondered the vastness of space, questioning whether what we see is all there is. But in recent years, scientists have begun considering an even more astonishing possibility that our universe might be just one of many. We are not just talking about other planets or distant galaxies. We are talking about the possibility of entirely separate universes, each with its own unique set of physical laws, histories, and possibilities. So, what is the multiverse? Multiverse is the idea that our universe is not the only one. There could be many other universes with different realities. Some might be similar to ours, while others could have completely different laws of physics. There are several scientific theories supporting this idea, and we will explore them one by one. The first theory is the inflationary multiverse. This idea originates from cosmic inflation, a rapid expansion that occurred moments after the Big Bang. During the inflationary period, different regions of space expanded at different rates. Some regions stopped inflating and became stable, forming bubble universes, one of which is our own. However, other regions continued inflating indefinitely, producing an endless number of new universes. Each bubble universe is separate from the others, meaning they do not interact. They may even have different physical laws, fundamental constants, and types of matter, making them radically different from what we know. This theory was first proposed by Alan Guth in 1981 as a solution to several puzzles in cosmology, such as why the universe appears so uniform on large scales. Later physicists Andre Linde, Paul Steinhardt, and Andreas Albrecht refined the idea, leading to the concept of eternal inflation. Although we cannot directly observe other universes, the inflationary multiverse theory offers explanations for certain cosmic mysteries, such as why the universe is so uniform and flat, the possibility of different physical constants in different universes, potential clues in the cosmic microwave background radiation that might hint at interactions between universes. The second theory comes from quantum mechanics, which states that at a fundamental level, particles can exist in multiple places at once, meaning they can be in multiple places or states simultaneously. This is also known as the many worlds interpretation. Every choice we make creates a branching reality. For example, in one reality, you are watching this video, but in another reality, you are doing something entirely different. The many worlds interpretation was first proposed by physicist Hugh Everett III in 1957 as a way to explain the strange behavior of particles in quantum mechanics. Instead of assuming that particles collapse into a single definite state when observed like Copenhagen interpretation, Everett suggested that all possible outcomes actually happen, but in separate parallel universes. While the many worlds interpretation remains controversial, it offers a mind-blowing perspective on reality that every possible event has happened and is happening in some other universe. This idea has inspired countless discussions in physics, philosophy, and even science fiction. Although we cannot directly perceive these other worlds, the many worlds interpretation helps explain some puzzling aspects of quantum mechanics, such as the double-slit experiment, where particles behave as if they take multiple paths at once, quantum entanglement, where two particles remain connected over vast distances instantaneously. Some physicists speculate that the Big Bang happened when two brains collided. If true, there could be another universe very close to ours. We just can't see or interact with it. In the late 1990s, theoretical physicists such as Paul Steinhardt and Neil Turok proposed that our universe could be a three-dimensional membrane, or brane, floating within a higher dimensional space. This concept comes from an extension of string theory known as brane cosmology. In this model, our universe is not the only brane in existence. There could be many parallel branes, each representing a separate universe, floating in a higher dimensional space called the bulk. These branes can be extremely close to one another, separated only by tiny extra dimensions that we cannot perceive. Although we cannot directly see these extra dimensions or other branes, the Brane Multiverse theory could help explain the mystery of dark matter, which some theorists speculate could be the gravitational influence of matter in a nearby brane. Why gravity is so much weaker than the other fundamental forces, it might be leaking into extra dimensions, and possible evidence in cosmic microwave background radiation, where subtle patterns might hint at past brane collisions. But can we actually prove the existence of a multiverse? One way is by examining anomalies in the cosmic microwave background, traces of the early universe. Some scientists believe that collision scars between universes might appear in this data. Additionally, experiments at the LHC are searching for particles that might provide clues about extra dimensions. If we find evidence of particles disappearing into another dimension, it could be proof of the multiverse. So what do you think? Are we living in the only universe? Or is there something much bigger out there? Share your thoughts in the comments.